Everyone, welcome to Module 6.2. In this module, we're going to introduce smart contracts development. I'm Michael Gord. I'm the Director of Operations for Ben and the founder of MLG, a blockchain development and consulting firm based in Toronto. You can find more about me at mlgblockchain.com. So in this module, we're going to go over the different types of smart contract programming languages. We're going to learn how to compile and test your smart contracts, and we're going to learn how to query your smart contracts. So there's many different types of smart contracting languages, and these are the three main ones. So Serpent is based on Python. Solidity is based on JavaScript and has become the industry standard. It's also the language that we're going to focus on for the remainder of this module. And Chaincode is based on Go, and it's used by IBM in the Hyperledger Fabric. So first, we're going to learn how to compile and test smart contracts. So the easiest and fastest way to compile a smart contract is by using the Solidity Online Compiler. It lets you quickly compile and deploy smart contracts. It lets you test the code in real time. It converts it automatically for you into bytecode, which is what you deploy to the network. It tells you how much gas you use for your smart contract, and it shows you the address the contract is deployed at. So this is the easiest contract you could possibly make. As you can see, this is the bytecode that it gives you, which is what you deploy to the network, and this is the Web3 code. So if you press create, it shows you how much your transaction is going to cost, and it tells you the address that your transaction is going to be at. So if you add in a variable, so if you add in a variable, you can see that it adds the amount of gas that it costs, because storing balances or variables costs gas. So you can see if you take that out, it only costs 87,000. Whereas if you keep it in, it costs 90,000. And also functions cost a lot of gas. So you can see this lessens the amount of gas. Also, making something public makes it so that you can query the smart contracts from the interface. So let's go into that now, actually. So a uint, which we had in the example, is a positive integer, and it has no maximum. An int is an integer. It can be either positive or negative, and it has a maximum value for both positive and negative. A constant is a variable that does not affect the blockchain. A constructor function runs one time, and it costs gas. And a public variable is a variable that can be called from a smart contract, as we mentioned. Okay, let's actually test this from Truffle. So Truffle does a lot of the work for you. It helps you simply connect the user interface to smart contracts and to the blockchain, and it's great for testing and development purposes. It does a lot of the work for you. So to download Truffle, you need to download Node, and then after you've downloaded Node, you do npm install Truffle, and then you do Truffle init. So I'll show you here. Let's connect to test RBC in a Truffle directory, and then we do truffle init. And you can see it created all of these folders for us. So this is the folder that is initiated when you do truffle init. So you have your app, which is your user interface. You have your contracts, which are .sol. So you can see this is a standard token contract for the Metacoin user interface app. ConvertLib is a standard for initiating libraries. So libraries you can call functions from. And migrations automates the series of scripts. So you put that here, and then you have your test folder and your it has the port and your build and stuff. So we are going to copy this. And paste it in here and then save. And then we're going to run truffle compile. And then we need to do the migration, so we do that here. And you can see it's getting called up here. And yeah, so it deployed right here, first contract. So as we saw, when you truffle init, it creates an app folder for the UI, contracts for the SOL, and migrations. You add your contract file to the contracts folder with a .sol ending. You run the command truffle compile. You add your contract to the migrations, and then you run the command truffle migrate, and you have successfully deployed your first smart contract. So now let's learn how to query your smart contracts and build some functionality into this. So to start, you're going to go to truffle console. And the truffle console is a JavaScript console. So here you can run and you can see your first contract object. Now you can awesome. So now you see your 1000 here, and you see that it called on the test RPC. So now let's figure out how we can change up this variable. So let's add in a new function. Let's call this deposit. Let's call the new value. Balance plus or equal to value, and it needs to return balance, which will cost gas. So running these will cost gas. So now we need to and this time when we migrate, we need to reset it again. So for that, we got started with a call. We went through Truffle console. We viewed the contract with contract.deployed, which gave us back the contract object. We created a variable for the contract, and then we called the contract with contract.balance.call. So this is the first way to interact with the blockchain. It's a call, which doesn't change the state of the blockchain. The second is a transaction, which needs to be mined and changes the state of the blockchain. We'll get into a transaction in the next lesson. Thanks for watching. If you have any questions or want to help me to improve this module, feel free to reach out in the Blockchain Education Network Slack. And these are a few of the credits and references that I used for this class.